Alright, we want to now look at the first derivative test and what it tells us, and we've kind of already discussed it, but now we can officially say it, that when when a derivative is positive in some interval, that means the function is increasing on that interval. If it's negative, that means it's decreasing. A negative slope means a decreasing function. And if it's zero, that means that it's constant at or on that interval. More often than not, it's going to be equal to zero. It's going to be constant at a specific point rather than for a big long interval. In most cases, I should say. So now we have lots of things that a derivative can tell us. Obviously, it tells us the slope. We said last time how it could give us critical numbers, critical points. We could then use those to find maximums and minimums. And now we can use all of the above to figure out increasing and decreasing intervals using this first derivative test. So let's look at an example of how we want to do this and what we can find out. So same thing we've done before. If we want to find all this information, critical numbers, relative max and min, increasing and decreasing intervals, all that begins with a derivative. So take the derivative, 3x squared plus 12x. I want to set that derivative equal to 0. I can also want to set it to anywhere where the function was undefined, which, well, in this case, there's nothing where either function is undefined, so we don't have to worry about that. So I can pull out a 3x, and I'll be left with an x plus 4. That means that my critical numbers will be when 3x equals 0 and x plus 4 equals 0, which means I have x will equal 0 and x will equal negative 4. Those will be my critical numbers here when x equals 0 and x equals negative 4. Now, to find which one of those are relative mins and maxes and all these, the rest of this, it's all dealt with doing our number line. So we're going to sketch a number line. Our numbers that we want to look at are at negative 4 and at 0. And in these intervals, what do we know? Well, we know that f prime of x will equal 0 at each of those, but now we need to do the test intervals around it. So again, let's start on here. When it's bigger than 0, we want to look at our derivative. When it's bigger than 0, we're going to have a positive times a positive, so this will be a positive number. That means that I have an increasing function right there. When I'm between 0 and negative 4, well, the x is negative then, so that will become negative. This will still be positive, so that means a negative number, a decreasing function. And then when it's less than negative 4, this is negative still, but now this will be negative as well, so we have a positive function, so we're increasing here. That means that negative 4 will be a maximum, and that means that 0 will be a minimum, because we're going from up, climaxing and coming down, hitting a bottom, and then coming back up. So it means our relative maximums are just 1 point. When x equals negative 4, we plug in to find the y value of positive 32. That's our relative maximum point. The relative minimum is at x equals 0, and the y value at that point is also 0. Now, as for the intervals where we're increasing and decreasing, it's increasing wherever we have a positive here. So that means that our increasing intervals will be from negative infinity to negative 4, and then also when we go from 0 to positive infinity. And then our decreasing interval is when the derivative is negative, which is from negative 4 to 0. Notice we are using parentheses, not brackets, because we don't want to include where the derivative is 0, because it's not increasing or decreasing at that point. Okay, let's look at the second example here, and we want to do the same thing. I would suggest pausing the video momentarily, giving it a try, and then restarting it to check your answers. All right, let's see how you did. We're going to do a derivative. F prime of x will equal 12x cubed minus 12x squared. We're going to set it equal to 0 and pull out a 12. 12 times, or we can also pull an x squared, and we'll be left with x minus 1 here on the inside. So that means that x will equal 0, or x will equal a positive 1. So we would draw our number line. That means that we have 0 and 1 as our points to look at. Here's what our derivative is of f prime of x. So what we want to see is, again, each test point. So if something's less than 0, this will become a positive number because we're still squaring it, and this will be negative. So positive times negative will be negative, decreasing at this point. From 0 to 1, we'll have a positive number for this, but then this is still going to be negative. So we're still negative. We're still decreasing during this time. And then for the last part, positive, positive, this becomes positive, increasing. That means this point, I went from negative to positive. That means I have a relative minimum. And then this point right here at 0, well, we're decreasing. We kind of level off, and then we decrease again. So this would kind of look like this if it was our function at that point. And then as we're coming over, it'll start to go back up, starting at this point here. So that's just a rough sketch of what this graph would look like. But in the end, what is that? Well, it's really nothing at all. So that means our critical numbers should be, like we said earlier, with x equaling 0 and 1. Relative maximums will be the maximum. Well, we don't have any. We shouldn't have any at all. The relative minimum, I have these backwards. There is a relative minimum. It is the negative 1 comma 1. And the relative maximum is at, well, there is no relative maximum, is what I am trying to say here, just not saying it very well. There is no relative maximum because we never go from an increasing to a decreasing portion. We only go from decreasing to increasing. That's why the relative minimum is 1, negative 1. Our intervals where we're increasing, again, from 1 to infinity. We started at 0, just look where we have positive. Now decreasing. Here's the trick. You cannot just go from negative infinity all the way to 1. You say, well, what about this? We have negative negative derivative, or keep decreasing. When we get to this point right here, sometimes we call it a saddle point even, but it ends up being a horizontal tangent. We're not decreasing anymore, just for that 1 split second. So we have to not include 0 in that interval when we're talking about decreasing functions. More examples to come.